titled Alternative Transportation System. Today we're going to look at the second topic under this course, known as components of an airport. And under components of an airport, we're going to look at airport configuration. So our topic for today is components, and under it we'll be looking at, so what do we mean by airport configuration? We said it is defined as the number and orientation of runway and the location of the terminal area relative to the runways. So under airport configuration, we're looking at two things: the number runways and the orientation, that's the direction, the location of that runway. So, and also the location of these runways relative to the terminal building or terminal area. The number of runways depend on the volume of traffic, and the orientation depends on the direction of the wind and sometimes on the area available for the airport development. So we talked about number of runways, and we're talking about orientation of runways. So this very one depends on the volume of traffic, and the orientation depends on the direction of the wind. So this one depends on wind direction, area available for airport development. Terminal buildings serving passengers should be located so as to provide easy and short access to the runways. The airport can be divided into two principal elements. We have the landing area and the terminal area. So we have two major elements of the airport. We said the landing area and the terminal area. Two, we have the terminal area. Under the landing area, we have the runways and taxiways. For the terminal area, we have the apron. These are what make up the terminal area. The buildings. We have the car parking areas, and we have the hangars, etc., the control tower, etc. So we can as well include control tower. So the airport system, however, induces a third element, namely the procedure and technique governing the control of air traffic in the air space surrounding the airport, commonly referred to as the terminal area traffic control. Together, these three elements constitute the airport system. In general, the runway and the connecting taxiway should be arranged so we're talking about the arrangement of the runway, and connecting taxiways should be arranged so as to want to achieve the following: provide adequate separation in the air traffic pattern. Then two, we have to cause the least interference and delay in the landing, taxi, and takeoff operation. So cause the least interference and delay in landing, taxi, and takeoff operations. Then the third one is that provide the shortest taxi distance, possible from the terminal building or terminal area to the end of runways. Then the fourth one should be provide adequate taxis or taxiways. So landing aircraft can leave the runway, as quickly as possible. To the terminal area. So these are ways through which the arrangement of the runway and the connecting taxiway should be done. So the runway, we delete this, the runway and the connecting taxiway should be arranged so as to provide adequate separation in the air traffic pattern, then cause the least interference and delay in landing, taxiing and takeoff operation, provide the shortest taxi distance possible from the terminal area to the end of the runway, then provide adequate taxiway so that landing aircraft can leave the runway as quickly as possible to the terminal area. And the next thing we need to look at is runway configuration and runway system. Runway configuration and runway system. So under it, let's look at the runway critically. Runway system. So here we have a sketch. We try to draw a sketch of a runway. Let's draw a runway. We have something of this nature. Then we have a sketch of the runway. We have this. Then we have this smaller section of it. Under this, we have this. So we first of all identify the blast pad. So this is, we call this the blast pad. So we have this. We call this area within the blast pad. We still have a small section here. So this is what we call the blast pad. And when we are defining this, we said that the runway system consists of the structural pavement. This is the structural pavement, or the structural pavement. So next we have the structural pavement. We say the structural pavement is the portion where the aircraft moves while on the runway. Then we have the shoulder, or this portion, this little portion here. We call this portion shoulder. So this is the shoulder. So the shoulder is adjacent to the end of the structural pavement. It helps to resist jet blast erosion and accommodates maintenance and emergency equipment. So the next thing we need to look at is the blast pad. We call it the blast pad. And what is the blast pad? It is an area designed to prevent erosion of the surfaces adjacent to the end of the runway, which are subject to repeated jet blasts. So most times when the aircraft is taking off or landing, the first touch is on the blast pad, so it helps to reduce erosion at the end of the runway. And we said here the ICAO, that is the International Civil Aviation Organization, requires about 100 meters, requires 100 meter space or length for the blast pad. Sometimes it can reach 120 depending on the type of aircraft. Next, we look at the runway portion we call the runway safety area. So the runway safety area is an area which is cleared, drained, and it includes the structural pavement, the shoulders, and the blast pad. It must be capable of supporting emergency and maintenance equipment, as well as provide support for aircraft should don't ever off the pavement for one reason or the other. The minimum length of this runway safety area required according to ICAO is about 83 meters. 83 meters beyond each end of the runway. So 83 meters beyond each end of the runway. It can also reach 300 meters depending on the type of aircraft. So the next thing we look at is runway configuration. Runway configuration. Many runway configuration exists. Most configurations are a combination of several basic configurations, and they include 1. Single runway. For the single runway, this is the simplest of the runway configuration. Here, hourly capacity in VF, in visual flight regions conditions, is equal to 50 to 100 operations. Then in instrument flight regions, IFR conditions, this will be equal to 50 to 70 operations, where VFR is equal to visual flight use, and IFR is equal to visual or instruments, call this instrument condition, flight 2. So we have a sketch of a simple runway, or a single runway, something of this nature. So we'll call this a single runway. So we'll call it a runway, something of this nature. So this is termed a runway. So this is a single runway. So next we look at parallel runways. The second part is parallel runways. So we said 2 and 4 parallel runways are common in most cases. The first one have the spacing where it is close. Most times this will be equal to, we have about 235 meters to 835 meters for close spacing. Then for intermediate spacing, we may have about 2,005, or we have about 835 meters to 1,435 meters for intermediate. Then for far runways, we have anything that is from 1,435 meters and more. So that is for the parallel runways. So a little sketch of it. We can have parallel runways in this form. I have something of this form. Let me use a ruler so that it looks more clearer. So I have something like this, a parallel runway. I have another one. So this is, I have a parallel runway this way, and the second one may be here. Remember we said that the orientation depends on the wind direction. So this is the spacing between 2 runways. So you have this, and what we mean by this is that it is close. So you can also have another runway or another 2 runways like this, 2 runways. So for this one, these ones are close. So we'll call this, you can call it close. Then for intermediate, then we have another 2 system of runways where we have this. We have 2 that are close. So we'll call this, we can have another one here, and we have another one here. This is the part. So we have this. So we have a runway like this. Where we have this. So here, these two runways are closed. These two runways are closed. But when the distance between these and this is greater than intermediate, that here is greater, let's say this one may be, let's say 100 meters, call this 100 meters, and call this 100 meters, the space between these two runways, 100 meters, maybe this one is about 400 meters, just in between the two close, we call this close, we call this close, and we'll call this in between them, between the close runways that we have. We call this one, we say this one is far, because this and these are close, this and these are close, but in between here 400 meters, so this is termed as far. So this is the arrangement of parallel runway. So the next type of runway we look at are the intersecting runway. The C type is intersecting runways. So for intersecting runways, so many of the airports have two or more runways in different directions crossing each other. They are necessary when relatively strong winds blow from more than one direction. Strong winds, only one can be used. For light winds, both runways can be used. So let's look at example of intersecting runway. And we'll have something like this. Let's use the ruler so that it looks very straight and neat. So when we have something of this nature, so this is example of an intersecting runway. It's straight, don't mind my drawing. So here we have another one which can be in this form. Then we'll have another one like this. So these are example of parallel runways, and intersecting runways. Here we have this, and this goes like this. So these are example of intersecting runways. So call this intersecting. We're editing it now. So that's what we call intersecting runways. So the next thing we want to look at is the D option or D types. That's the open V runway. Open V runways. So for the open V runways, we said they are necessary when relatively strong wind blow from more than one direction. So when we have relatively strong wind blowing from more than one direction, so strong wind, only one can be used, while light wind, both can be used. So let's look at example of it. So I have something of this nature. So I have this in the runway. So for this, we still have another one of this way. Then we have this. How do we differentiate these diagrams? Let's see. For this one, the wind might be blowing in this direction, so the direction of wind, or this direction. So for this one, what we have here is blowing to this direction or towards this direction. So you can have one blowing here, another one blowing here, or this different direction. Then this very one, you can have one blowing to this direction, and we have another one blowing towards this direction. So likewise, this very one, you might have this L, and this is the direction of this very one. So for this one, you have wind blowing in this direction, and here you have this. So this is an example of open V runway. So after this, the next thing we look at is the taxiways. We look at the taxiways. We look at the terminal building. We look at the aprons. So here, taxiway, we define taxiway as a path on an airport connecting runways with ramps. So when you have runways connected with ramps, it is achieved using a taxiway. So the runway can be connected with ramps, hangars, terminal building or terminals, and other facilities. Then for the terminal building, known as the airport terminal building, these buildings are the spaces where passengers board or alight from flights. So it is used by passengers for boarding and alighting from flights. These buildings house all the necessary facilities for passengers to check in their luggage, clear the customs, and have lounges for wait before disembarking. The terminal or the terminals can house cafes, lounges, and bars to serve as waiting areas for passengers. Ticket counters, luggage check-ins or transfers, security checks, and customs are the basic of all airport terminals. Large airports can have more than one terminal that are connected to one another through a linkway, such as walkway, sky bridges. Smaller airports usually have only one terminal that houses all the required facilities. So for aprons are where the aircraft park. Aprons are also called ramps, so we call it ramps. They vary in sizes from small areas that may hold about 5 to 10 planes to a very large area that major airports do have. Unlike the runways or the taxiway, vehicles can use aprons. Care must be taken to avoid accidents involving vehicles and aircraft by adhering to rules of driving a vehicle on the airports. The next thing we look at is the aircraft stand. What is it used for? It's a portion of an apron designated as a taxiway and intended to provide access to aircraft stands only. Then control tower. What is it used for? The control tower is an airfield from which air traffic is controlled by radio and observed physically and by the use of radar. So it is controlled, or aircraft are controlled using the control tower by radio or through physical observation or by radar. Then we also have parking. The parking is a specific area of airports at which vehicles park. So this is used for parking of vehicles. So the next thing we need to look at is recommendation of ICAO on airport operation. Recommendation of ICAO, International Civil Aviation Organization, on airport operation. So here ICAO promulgates standards and recommendations on airports or airport operational efficiency for international airports, and where these have on safety impacts. So ICAO promulgates standards. ICAO promulgates standards and recommendations on airports. ICAO promulgates standards and recommendations on airport operational efficiency for international airports, and where these have an impact on safety. States have further criteria and standards specific to the characteristics of national airport operation. So, for passenger terminals, ICAO recommends the following practices. For terminals, passenger terminals, it recommends that 60 minutes of international departure passenger processing from presentation at first processing point to schedule time flight. Then 45 minutes for international arrival passenger processing from embarkment or disembarkation to completion of the last clearance process. So next, we look at criteria for airport site selection. That's the next thing we have to look at. We look at criteria for airport site selection. What are the requirements or criteria used for airport site selection? Criteria for airport site selection. So the first thing we have to consider here, we said the selection of a suitable site for an airport depends on the class of the airport under consideration. However, if such factors are required for the selection of the largest facility, are considered the development of the airport by stages will be made easy and economical. The selection of a suitable site for an airport depends on the class of airport under considerations. So under this, we're going to be looking at one, we consider regional plan. So whenever we are siting a new airport, the sites should be selected to fit well into regional plan, thereby forming an integral part of the national network of airports. Yes, it's very important that regional must have regional plans must be considered. Then airport use, what are we using the airport for? Are we using it for civilian? That's the first one we said, regional plan. The second one we want to talk about airport use. What are our intended use of the airports? Is it for military or for civilian? Or is it going to be for domestic or international airports? So the use or the selection of site for airport depend on the use of the airport, whether for civilian or military operations. However, during the emergency, civilian airports are taken over by defense. Therefore, the airport site selection should be such that it provides natural protection to the area from the road. This consideration is of prime importance for the airfield to be located in combat zones. Then proximity to other airports. The site should be selected at a considerable distance from the existing airports so that the aircraft landing in one airport does not interfere with the movement of aircraft at another airport. So most times we avoid siting airports too close to avoid collision of aircrafts. So the required separation between the airports mainly depend upon the volume of air traffic. The next thing we have to look at is the third one, which is ground accessibility. Ground accessibility. The site should be selected that it is readily accessible to the users. The airline passenger is more concerned with his door-to-door time rather than the actual time of air travel. So the time it takes to get to the airport matters to the airport user, considering where he is traveling to. So topography is another important factor. Topography. This includes natural features like ground contours and trees, streams. The lowest ground hilltop is usually considered to be the ideal site of an airport. So we'll also look at the fifth one, which is obstructions. So when an aircraft is landing or taking off, it loses or gains altitude very slowly as compared to a forward speed. For this reason, long clearance areas are provided on either side of runway, known as approach areas, over which the aircraft can safely gain or lose altitude. So we also talk about the sixth one, which is visibility. The visibility, so it's also important because poor visibility lowers the traffic capacity of the airport. The site selected should therefore be free from visibility. It should be free from visibility reducing conditions such as fog, talk about smoke and haze. Then the next thing we look at is wind. So most times wind is an important factor. So runway is so oriented that landing and takeoff is done by heading into the wind should be collected over a minimum period of about 5 years. So most times wind studies should be carried out for up to 5 years. The next thing we look at is noise and nuisance. The extent of noise nuisance depends upon the clamp part of the aircraft type or the engine proportion. So most times we should also consider noise, especially for people who are living around the airport. So we consider in such a way that the noise from the aircraft will not be interfering with normal lives of people who are living around the area. The airport should be sited away from highly or densely populated areas. Then grading, drainage and soil characteristics are also important. Then we say 8, we said drainage, grading and soil characteristics. So grading and drainage plays an important role in the construction and maintenance of airports, which in turn influences the site selection. The original ground profile of a site together with any grading operation determines the shape of an airport area and the general pattern of the drainage system. The possibility of floods at the valley site should be investigated. Sites with high water table which may require costly subsoil drainage should also be avoided. So viewers, this is where we come to the end of today's lecture on airport configuration. If you'd like to subscribe to our channel, do so by hitting the subscribe button, turn on the notification icon, and you'll receive updates whenever we post new videos. For now, this is Engineer Bona Namdi. See you in the next video. Bye for now.